Okay, hello everyone. Let's go ahead and take a look at the properties of definite integrals. Now there's a fact that we're going to have to be careful of because it is going to determine whether or not the area which is provided by your definite integral is actually going to be positive or negative. And so in that case, yes, area given by a definite integral can be negative if the area is below the x-axis. Okay, so let's take a look at a particular function that I've drawn here. And let's say that we just have a line. Okay. Now if we go ahead and take a look at the definite integral from 0 to 2 of f of x d of x, and we know that this is actually going to be the area that is bounded by the function 0 and x equal to 2 and the positive x-axis, then this area here is going to be represented by that definite integral. Now if we go ahead and calculate the area itself, this is going to be a base of 2, a height of 2, and multiply those two, which is 4, divided by 2, that is going to give us an area of 2, which is, of course, a positive value. Now, in the same respect, if we look at this function and we take the definite integral from 2 to 4 instead, let's say, then I'm talking about this value right, this triangle here, and if I was to go ahead and take a look at that area there is actually going to be a negative area. Now, why is that a negative area and this a positive area? It's because of the fact that the height in this triangle here is negative 2. Now, where are we coming out with that negative 2 value? When we went ahead and took a look at the height of the triangle is actually determined by the y value of the coordinate at this point. So we know that this is going to be a 0, 2. So we said then that the height of the triangle is actually going to be 2. Which therefore gave us a positive area. But when we take a look at this value here, the height of the triangle, which is described by that value right there, that length, is actually going to have a y-coordinate of negative 2. And because of that fact, the base is still going to be 2, but the height is now a negative 2 value. So therefore your area is actually going to be, in total, negative 2. So what can happen then is that you can actually have a negative area if your area is below the x-axis. And it's because of the fact that the heights that is determining the area is actually going to be a negative value. So that's going to be something to keep in mind. Okay? Now, there are other properties that we're also going to have to take a look at as well. And one of these properties is the first one here, which is number 1. Is the definite integral from a to b of negative f of x d of x is the same thing as the opposite of the integral of a to b f of x d of x. Now, why is that true? If we were to go ahead and take a look, say for example, this particular function here, and let me go ahead and erase this part since we're finished. If we were to go ahead and determine what the opposite of f of x is, the opposite of f of x would be this. It's a reflection, it's this right here. It's a reflection about the x-axis. Okay? That's what the opposite of f of x looks like. Okay, now, let's just go ahead and take a look at what's actually being said here. If I was to go ahead and take a look at the integral, this is property number 1, the integral, let's just say from 0 to 2 of the opposite of f of x. So the opposite of f of x is going to be that function which is with the green, d of x. Is that going to be equal to the opposite of 0 to 2 of f of x, d of x? Now, if we go ahead and take a look at the areas that are represented by these two functions between 0 and 2, notice that the area is going to be exactly the same, except for the area, one area is going to be positive, this one is going to be positive, and this one is going to be negative. So therefore, what we're saying then is that in order for those two to be equal, we just have to multiply it by a negative. And so that's why I multiply this by a negative. So in that sense now, these two values there would be equal. Now, in terms of actually going about calculating areas later, all we need to really remember is that if you have a negative scalar multiple here, you can just put it out in front of the integral itself, and it is going to be equivalent. Okay, let's take a look at the next one. The next one is very similar to it in the sense that instead of -1, it can be any constant that you want. So you could have -2, -5, 10, pi, square root of 10. It doesn't matter what you're going to have. If you have a constant multiplied to the function, you can actually move that constant out in front of the integral and you will still have an equivalent integral. Okay, let's take a look at number 3. Okay, number 3 says, if you have the integral from a to b of f of x d of x plus the integral of c to b, from b to c of f of x d of x is the same thing as the integral from a to c of f of x d of x. The most important thing for you is to recognize where a, b, and c are for you to understand exactly what this is. So let's just start off with the value of a, and let's just start off again with 0. So this is property number 3. 0 to 2, let's just say, of f of x d of x. Again, that's what our f of x is, and it's going to be represented by that triangle there, the area. Let's say, for example, that, notice that in this property here, this upper limit is the same thing as the lower limit there. So that's the lower limit, 2. And then I have to choose an upper limit. Now an upper limit, of course, has to be bigger than 2, so let's just say 4 of f of x d of x. What this is saying is that if this is the case, you can actually simplify this to the area between 0 to 4 of f of x d of x. Okay, now is that true? If I was to go ahead and take a look at the area of here, which is represented by that, plus the area here, which is represented by the area there, is that actually going to be exactly the same thing as the area of this plus the area of that? And sure enough, it is. So notice the main thing that has to happen though is that your a is the lower bound here and here, b is in the middle, and c is going to be the final upper bound. Okay, and the function doesn't change. Okay, so let's take a look at the last one then. The last one says if you have the integral from a to b of f of x d of x plus or minus the integral from a to b of g of x d of x, then you can actually add the functions first before actually integrating. So let's just take a very simple example here, and let's say that our second function, g of x, is this. Now, if I was to go ahead and take a look at the integral from 0 to 2 of f of x d of x plus the integral from 0 to 2 of g of x d of x, is that actually going to be exactly the same thing as 0 to 2 of f of x plus g of x d of x? Is that area actually going to be the same? Now, if I go ahead and take a look at what this represents here, that represents again the area of the triangle. This over here represents the area of that right there. So you have a triangle plus a rectangle. Now what this is saying is that I actually have to add f of x and g of x together. So if I add f of x and g of x together, this is what I come up with as a function. It's here, and then it's going to be here, and then it's going to be here. So it looks like this. Okay? And so what it says then is that this function right over here, which is f of x plus g of x, this is f of x plus, f of x plus g of x, the area that is under here, from here to here, that trapezoidal area is exactly the same thing as the area that is given by this triangle plus that rectangle. And it should be pretty obvious to you, because if I just take this triangle and shift it up one, it becomes that triangle there, and the areas are exactly the same. So, there you go. Those are the properties of the definite integrals. We'll go ahead and take a look at how to apply some of these to some of the problems in the text. One quick question that I'd like to see if you can answer, and this is something for you to consider, is what might be the values of a, b, and f of x such that the integral from a to b f of x d of x is equal to 0. There are many situations that that's possible. If you can determine some integrals that actually make that true, then you've got a pretty good idea of how to work with these properties. Okay, give it your best shot. Let's see how you do. Good luck. See you next time. Bye.